Hello students, in this session we will be discussing the topics which is DBMS architecture as well as different types of architectures. Now previously I have done a method where I have displayed the PDF notes by which I have tried to explain the topics. I think some students have felt that this method is much better than the previous method, so I will be doing the same method here. This is the second chapter, so where I will be taking the concept, that is database management system architecture. Now database management system architecture here, first as I say, architecture is nothing but the software will be divided into these three modules, like physical level, conceptual level as well as external level. Okay, so the software will have three different functionalities. One, that is physical level, conceptual level as well as external level. What is external level? External level is nothing but where the user is going to interact with the software. So this is our application, or this is our software. This DBMS software will be divided into these three levels, where whatever information is displayed to the user, or whatever user wants to, whenever user wants to give some queries, or if he wants to give some questions, or if he wants to give some information to the software, it is given through the external level. So external level is module, or is in the level in architecture where the user is going to interact with the DBMS software. Okay, there you can see the functionalities for the user, as well as different types of users will be having different types of interfaces, like say command user interface, or graphical user interface, or application based interface. Those type of interfaces will be provided by the software based on the different types of users, and different types of users will get different types of interfaces. Okay, that is, will be representing external view 1, external view 2, up to we'll have different types of external views for different kinds of users. Okay, so that is about external level. So coming for the next level, which is conceptual level. Conceptual level usually stores, or it is also called as logical level, where it is going to store description. So whenever I say description, it is nothing but structure. It is nothing but the structure of the database. In the sense, as I told you, if you have a database, it will be having collection of tables. It is nothing but each and every table will contain its own data fields, its own data type, its own constraints, like whether it is a primary key or not, whether it can be null, it can be empty, or it can have any default value. So those kind of informations are nothing but description of that particular table. Similarly, conceptual level will hold the information like description or structure of the table. While coming for the next level, which is physical level. Physical level is a level which contains the information of storage details. Storage details is, this will represent your memory device, like your hard disk, and how the data will be stored into memory devices, in which location it is stored, how it is organized, how to access the information, those kind of information, which format the file is, those kind of information will be stored in the physical level. Here external level we have, where it will be like your interface that will be given for the user, and conceptual level, it will contain the description details. It is also considered as logical level. When you consider internal level, it is also considered as physical level, which contains the details of the storage details, how it is stored, where it is stored, in which format it is organized. Those kind of information will be present in the physical level. So in between these things, we'll have a concept called as mapping. Okay, so what is mapping? Mapping is nothing but, it is simply to say, it is going to identify, or it will help one level with the other level to access the information better. Okay, so it is nothing but it will help in accessing the information. So that process will consider it as mapping. For example, we have already studied some concepts regarding how to create a table and how to access the table. Say if I consider I have simple table, that table name is suppose to say I'll consider the table name as student. It will contain some columns. Say I have register number, name, as well as date of birth. These are three fields I have. So as you know, this will be like number, this will be varchar, that is string data type, and this will be date. Okay, so this represents the structure, that is description of the table. The table name is student. It contains three columns or three fields, and its data types are number, varchar, as well as date. And number, I can say I can store up to 28 digits into the register number, and name I can store up to 50 characters. Date, as you know, you can store date, will be having both date as well as a month as well as a year. Okay, now this will represent the structure, that is description of the table. So when the user gives a value like select star or asterisk from, what is the table name? The table name is student. So whenever I represent this, the external level will be accessed by the user. So the user is going to give the information to the software with the help of this external level. I am going to give this information to the software. Once that is given, it will enter into the conceptual level. Here we'll have conceptual level mapping. So what is conceptual level mapping? Here it is going to check whether there is any table called as or description called as student or not. Okay. In that it is going to check how many columns you have. Suppose I want to access only name. If I want to access only name, I'll be giving select name from student. Now it is going to check whether name is present in this structure or not. So it is going to check the description, whether the given that is a table or database, what it is, in that you have that particular name or not, that field is present or not, that will be checked. That is, mapping between external level and conceptual level will be done. Okay, once that is done, if that is existing, then it will go to the physical level. In the physical level, what it is going to do, it is going to access that name's values where it is stored in the hard disk. So it should search in which location it is stored, how to access that particular database or particular table. Those things will be done in the form of mapping between conceptual level as well as physical level. So there will be two types of mapping, one between external level as well as conceptual level, and one more between conceptual level as well as physical level. In first we will be considering or we will be finding the description of that particular information what we are searching for, and the second level we will be searching for or accessing the path where the actual location of the data is present. So that is about the architecture of DBMS. Okay, now this is architecture. This architecture will be present, like say it will represent only when you have a single system and you are going to use that you are going to use the software in that particular system only. Okay, now coming for the other types of say architectures, we have one type of architecture called as centralized architecture. What is the meaning of centralized architecture is, suppose I have, so I'll just represent it in the form of, so I have a single system. Okay, so I have a single CPU or a processor. In that processor, I'll have the DBMS software, database management software will be present in that single system, and the single CPU will be connected with multiple say monitors. Okay, so when I say monitors, it is nothing but these will be acting as clients. These will be acting as clients, in the sense these devices will not have any memory location, or it will not have its own operating system or anything. It will have its own input devices like keyboard and mouse, and it will have its own output device which is monitor. Okay, now this devices will be connected to one single server. Okay, so which contains the software which is database management application. So this type of representation will consider it as centralized architecture, where we'll have different types of workstations or clients. So it is called as workstations, and different number of workstations will be connected to a single system where you will have all the information will be placed in a single device or single system. It is nothing but your server. Okay, so that is centralized architecture, where all the information will be stored into one location. It will have multiple workstations, where each and every workstation can access the information which is required for that particular workstation. Okay, now coming for the next, which is distributed. Now what is the problem with this single server is all the information will be stored in a single server, so that even though this is powerful enough to manage the workstations, it will be giving less performance, because every action given by all the workstations should be done by a single CPU, or a single device will be doing all those functions, which will lead to inefficiency. So the CPU cannot do all the functions fast enough. Okay, for that purpose we'll come across distributed database management system. Okay, so distributed database management system architecture, in this type of architectures you will not have only a single server, you will have different servers. Okay, different devices for different functions. Say for example, I want to access an image, or I want to access a MS Word file or something like that. For that I will be having different server, which is file server. So whenever a client wants to access say for example files, it will go to this device. Suppose I have some other function, say for example I want to access, I want to print some value, I want to print a given file. In that case the information will be sent to different server, that is print server. Like that the functions will be divided based on the based on the functions we are going to have different servers. That is nothing but distributed database management system. In this type of architecture we'll have different types of servers for different types of functions that can be accessed by all the workstations, where the work will be distributed so that the functions can be done faster, and it can be like say more work can be accessed with the help of different types of servers. That is distributed database management system. That is one type of architecture. And apart from this, we'll have one more type of architecture, which is called as client server architecture. In the concept of client server architecture, the same like say architecture will have, what we are going to have is, we'll have different types of devices, and each and every device will have its own functionalities, and that particular functionalities will be represented in different ways. Like say for example, I have a server and I have a client, and again I have some other client or server and some other client I have. Okay, these two devices will be connected with a network. Okay, so like that you can have any number of clients and any number of servers. Okay, so in the sense I'll have many servers, I'll have many clients, and those servers and clients are interconnected with the help of some kind of network. Okay, so this type of formation will be seen in client server architecture. Okay, so I'll just explain what is that. Under client server architecture we have two types, one is 2-tier architecture, other one is 3-tier architecture. First we'll see what is 2-tier architecture. What is 2-tier architecture is, we'll have only two functionalities there, one is client, other one is server. Okay, so client is the device which will be requesting, which will be sending request for some information. Any device which is giving a request for information will be acting as client. Any device that will be providing, say which has the information, that particular device will be acting as server. Say for example, I have this computer 1, and this computer 1 needs some file called as file1.txt. Okay, this particular file will be requested by system 1, and that particular file is present in, say this server 1, I'll name this as server 2, and this is system 2. Okay, this will be system 1. System 1 is requesting for a file called as file1.txt, which is present in server 1. Okay, now S1 will be acting as what? That is client. System 1 will be acting as a client, and the server 1 will be acting as what? Server, because it will be giving the information. Okay, the same thing if you observe, say for example, if the file I want to search is file2.txt, it is present in some other server. In that case, when the client has requested for that file, if it is not present in this particular device, through the network it will go to the next server, and the next server it is going to search for that file, and that information will be sent back to the system 1. So this type of representation we will consider it as client server architecture. So client server architecture is an architecture where the clients will be requesting for the information, and will have several servers which will be connected through the network, which will be providing the information to the client. Okay, so here we have several other concepts. So in client server architecture we also have the concept called as ODBC, as well as we'll also have something called as API. I'll just discuss what is that. So what is ODBC and what is API? So before that, I'll just discuss a program as well as DBMS. Okay, a program. So consider you are writing a C program, and that program needs some information or data. That data is present in database management system. Sorry for that. I have a C program, and this C program needs some information or data. That data is present in database management system. Now if you see, this is a different software and this is a different software altogether. This is C programming. We will be using, say, Turbo C for doing C programs, and you will be using Oracle 10G, or you will be using other applications for implementing database management system. Now I want to send the information from Oracle to the database manager, that is, say, Turbo C, right? So in that case we'll come across this concept called as ODBC. What does ODBC stands for? Is ODBC stands for Open Database Connectivity. Okay, so Open Database Connectivity, it is nothing but, so it will be acting as a driver software. It will be acting as a driver software which will be helping us to access information that is present in database management system to some other program. Not only C program, you can access in C++, you can access in Java, you can access in different types of programming languages, but we need particular drivers for that. But usually you will be learning something like Visual Basic, and you will be connecting that particular Visual Basic software or Visual Basic programming language by which you will be accessing the database management system. Okay, that is DBMS. So Open Database ODBC is nothing but it is a driver, or it is also considered as API. It is nothing but application program interface that will help us to connect one device, one language with other language. Now in this case, C program is accessing information from what? DBMS. Now C program will be acting as client and DBMS will be acting as what? Server, because it will be providing the data to this particular programming language. Okay, so not only like this, for every transactions you make, or say whenever you send some query, or whenever you give some question to the database management system, so all those things will be working in the form of client server architecture. So we will have client and server, as well as we can also have a single server which will be acting as both server as well as client. Okay, so these type of representations we will see in two-tier architecture. Okay, now we will have only two levels there. One level will be client and the other level will be server. Now coming for three-tier architecture, we are going to have three levels there. One is like your interface, which is GUI, and you'll have your actual database. In between you'll have something called as application server. Okay, so in 3-tier architecture you're going to have 3 levels. One is like where you're going to have your external interface, graphical user interface, and then it will be followed by the server. In between that you're going to have application. Okay, so what is the difference between this 2-tier and then this 3-tier? In 2-tier architecture you're going to have only client as well as server, but in 3-tier architecture we have going to have 3 levels, where first you're going to have the external level like your client or something, and the application level. Application level layer, it is responsible for that is, say, before giving the information or before providing the information, if you want to provide some, say, authentication. For example, if I am the user, I want to access that server. Before accessing that server, I need to have that username as well as password. For example, it is like if you are storing the information in the hard disk, any user can access directly that particular information that is present in the hard disk. Suppose, say, if I am storing the same information in the Google server or somewhere like that, in the servers, now I want to access my Gmail or I want to access my Google Drive. In that case, without my username as well as password, I cannot access that information. That is like your application server or web server. Okay, so we have 3 tiers there. One is like GUI or the user interface, and the server. In between that you will have the web server as well as application server, which will be managing the information which you are going to access from the server by making it as, like, say, providing authentication, or if you want to avoid some information to be transferred to the server or access information from the server, that will be handled by your application server. That is 3-tier architecture. So these are the types of architectures you have under your database management system. Here we will be mainly concentrating on the first DBMS architecture, and you should concentrate on client server architecture with 2-tier. Those 2 topics are important. Now at last, coming for the last topic, which is data independence. What is data independence? Data independence, we have 2 types of data independence. One is conceptual data independence, the other one is physical data independence. Okay, what is the meaning of conceptual data independence and physical data independence? I told you we have 3 levels there: external level, conceptual level, as well as physical level. Conceptual level will hold the information like description. Description in the sense, what is the structure of the table, what is the constraints, those details will be present in the conceptual level. Now, what is the meaning of conceptual data independence is, if you make any changes to the, say, for example, to the description of the table, that will not affect the external level. Okay, in the sense, say for example, I have given register number, name, as well as date of birth, and the user has created this and is he is accessing this values. Suppose I'll add one more column here. I have date of birth, I'll add one more column, say for example age. Now that is nothing but I am making changes to the structure of the table. Previously we had only 3 columns, now I am adding one more column. So that is, we have 4 columns now, or 4 fields now. So that is nothing but I have made some changes to the structure that does not affect the previous information or the external level in the architecture. That is conceptual data independence. Hope this is clear. Suppose, say, if I am added some value 1, this number is some name is X and date of birth is 2022 or something, age is some 20 years, so I'll write 2000. Okay, so if this is the data, and I'll add one more column here, I'll add one more column, say address. In this case, if I see this information, I'm already added these values and I'm adding one more field there. In this case, this does not affect the data. So that is like your conceptual independence. Now coming for physical data independence. Physical data independence is, say if you are having the like say physical data independence is nothing but it deals with where the data is stored, the location where the data is stored, that information will be provided by physical level. Now if you make any changes to the physical level, in the sense if the system organizes or the system changes the location of the file, or if the system increases the location size of the file, or if it makes some changes to the file, like say renaming the table name or renaming the database name, if I do that, that will not affect the information or the structure of the table. Say for example, the table name is student. Now I'll rename it, or I'll name it as student 1 or student 2 or BSc student or something like that. I'll change the table name. In that case, the information that is present in the table and the description of the table does not change. It will only change the physical location of the particular change while organizing the tables. So these kind of changes, we'll consider it as physical data independence. Fine. So these are the topics that we have cleared today. In the next session, we'll be seeing the next topic. Thank you.